So today I'm going to be talking about just basics of using WestGrid. I hope that everybody has an account and that everybody has tried to log into Jasper, because we'll need to do that. But anyways, once we get to that point, we'll try to straighten everybody out. So as I mentioned, we're going to be working with one of the WestGrid clusters called Jasper. It has 240 nodes with these X5675 processors, which are newer than the 160 nodes with the L5420 processor. So there are two kinds of computers in this processor, in this cluster. The newer ones have 24 gigabytes of memory, and the older one have 16. And they're all connected by a high-speed InfiniBand network, and there's a connection to a large distributed file system. So the way you use a cluster is that you're at your desktop machine, and then you would log into what's called the head node or the login node. So that's what you do when you connect to jasper.westgrid.ca. And from there, all the runs that you want to do should go to the compute node. So there's no work being done on the head node except for compiling and testing, and basically it's used for submitting batch jobs that are then run on the execution nodes or the compute nodes. Okay, So to do all that, you need some sort of software for connecting to WestGrid. On Windows, we now recommend using a software called Mobaxterm. On a Mac and Linux, on a Mac and Linux systems, you already have the software for connecting, but you also, on a Mac, you will, if you have a newer Mac, you will need to install an additional software called Xquartz for doing graphical interactions. So I've given the link for doing that. So before I go on, is there anybody who has not logged into Jasper yet? Can you just either speak up or say on the group chat?
Oh, I've logged into Jasper. Not logged into Jasper.
Not logged into Jasper.
I wouldn't bother.
Okay, so we do have people who have not done it. Okay, so I'm going to go through the steps first for mainly for Windows people, because that involves installation of software. So the first thing you need to do is to install Mobaxterm. If you Google Mobaxterm, you will find the web page, and there's a place for downloading the software, and you can choose either the portable edition or the installer edition. If it's your own machine and you're able to install software, I would recommend you do the installer version. If you don't have the installation abilities, choose the portable edition that will just create files in your own directory. So can anybody who hasn't logged into Jasper and has Windows machines do this right now? So we're just going to wait maybe 5 minutes until people hopefully have installed Mobaxterm. If you choose the portable edition, what you will get is a zip file. And once you extract the zip file, you should get a folder with these 3 files. Yeah, I see in the chat window somebody's talking about WinSCP. WinSCP is for transferring files. If you were using that, you probably installed PuTTY. That's a different kind of program. If you're using PuTTY to connect to Jasper, you may want to install another program called Xming. So the letter X and MING. Yeah, so if you already have a Mobaxterm, just wait for everybody to go on, because this is a workshop, and I do need everybody to be able to follow along. So, and people with Macs and Linux boxes can just wait as well.
Hello?
Hi. There's 3 of us watching here from UBC.
Hi there.
So you guys okay from UBC?
Yeah.
Okay.
Yeah, we'll just ask you guys keep your microphones muted, please, if you're not going to be speaking or asking questions. Thanks.
Going off, but maybe.
Take the microphone.
Okay, so if you're ready with Mobaxterm, you can click on the software, and it should start up. You should get a screen like this, and then you can start your local terminal. People with Macs or Linuxes can open a terminal window. After that, it should be same for everybody. Once you start local terminal on Mobaxterm, you should get a window like this. And you can type in SSH space -y space your WestGrid username at jasper.westgrid.ca, and it should give you a prompt for a password. Another thing you can do with Mobaxterm is actually transfer files, and that sort of works like WinSCP, that you can drag and drop files into the column here to transfer files. So as I said, for Mac or Linux, just open up a terminal window, and you can type the same thing, SSH space -y space your username at jasper.westgrid.ca. And that should get you into Jasper. So we'll just wait a bit. So somebody's asking what does -y do. -y allows you to do graphical applications that we may want to use. So is anybody not logged into Jasper yet? either speak up or put in a group chat window.
Sorry, could I ask a question? I'm not sure where the group chat window is. I'm viewing this in a browser.
Okay, in a browser. Well, I'm not sure how the browser works, but if on a regular app, if you move your mouse down to the bottom of the screen, there's all the controls pop up, and there's a bubble, like icon. You click on it, and it should open the group chat. I don't know if Jana?
I'll interrupt you there, Masao. Chat is not supported on the web connections, folks.
Oh, okay. Yeah, so if you can just speak up then, if you have a question.
Okay, sorry, thanks.
Yeah, so while people are still trying to log in, you can do transfers using these programs as well. On the Mac or Linux, there's a command called scp, and then you can copy files. So you would give your file name first, and then you would the destination would be your WestGrid ID at jasper.westgrid.ca and a colon, and that colon is very important. You can also install on these machines graphical programs for transferring files. One example is FileZilla. And on Windows, as I pointed out, you can use Mobaxterm or WinSCP to do graphical transfers. You can also do SCP from your Mobaxterm window as well. Okay, so I hope by now everybody's logged in. So that if you still haven't, just SSH space -y, your WestGrid ID at jasper.westgrid.ca. As I mentioned, this is a login node, and interactive use, which means just typing at the terminal window, should be done only for compiling, testing, debugging. You can run small tests which should be less than an hour, and you shouldn't use more than 2 cores. If you need longer interactive use, there is a way to do it, which is called an interactive batch job. I'll talk a little bit more later. And so there's a command for doing that, qsap -I. Now, today, as this is a workshop and we want to have a good access to our compute nodes, we've created a sort of a mini cluster within the Jasper cluster. And so after you've logged into Jasper, you need to do another SSH -Y space CL2N230. So that's a letter L, the CL, to N230. So could everybody do that now? So that will get you into another. In fact, it's a compute node, but we've set it up so that it behaves like a login node. And from there, we have a small cluster behind it that we'll be submitting jobs to. The node name, well, it's on the screen, CL2N230. So this is the second character is a lowercase l. So who is not yet on CL2N230? Everybody okay? Okay, once you're there, I want you to copy some files. So cp is a command in Unix for copying. There's a file in my home directory called workshop.may2016.tar.gz. The way this command works, copy command, the first argument is the file that you want to copy. The second argument will be where you want it copied to. Now, what I've typed here is a squiggle, which means when in Unix, when you type squiggle and a username, that refers to the home directory. So this squiggle Fujinaga refers to my home directory. And then you have a space and a dot, which refers to a current directory. So what you're doing is copying a file in my home directory to where you are, which should be in your home directory. And once you've done that, we're going to unpack this file. This file that I'm asking you to copy is what's called a tar archive. It's sort of like a zip file in Windows. So it's a collection of files all put into one file, and then it's been compressed. So the tar refers to the, I guess the name comes from tape archive, and the GZ is a compression format. So this has been put into a tar file and then compressed. And the next command, tar -xf space workshop may2016.tar.gz, extracts the contents of the file. And that's going to create a directory in your home directory called workshop may2016. And you can change to that directory by giving the command cd workshop may2016. So I want everybody to do these 3 steps.
Hi, one question.
Yes?
It says my connection timed out. Is that what happened?
At what point did the connection time out?
Connecting to Jasper.
Connecting to Jasper. What software are you using?
Mobaxterm.
Mobaxterm. Oh boy. Recently we had a person have some problem with Mobaxterm. I'm not sure if it's the same sort of problem you're having. You don't have another computer that you can use or something? Are you on a wireless network or wired?
Wireless.
Wireless. The only thing I can suggest now is install another program called Putty. I can probably find you a link. Yeah, if you Google Putty, it'll get you to this page, and there's a download link. The setup is a bit different, but you can try that. Everybody else okay with these 3 steps? Okay, before we actually do some work, just some background on how things work in WestGrid and Unix. A lot of working in Unix requires setting up various environmental variables, so-called. They allow the system to find programs and libraries. And on most WestGrid systems, the environment is controlled through something called modules. And on any WestGrid system, you can type module avail to see all the available modules. On Jasper, we've divided up or organized the different modules of it according to whether it's an application, a compiler, a library, utility, or U of A specific modules. So when you type module of A, you'll see something like this. The slide is a little older, so now the list is actually longer. But you can try it on your connection. You'll see the modules that look something like this. So I've got applications, and the list goes on to show compilers, libraries, and so forth. And to use these modules, you'll have to load them as you'll see later. Another way to find out what software is available is to go to the WestGrid website. We have a list of software. Hopefully it's up to date. Sometimes it's not. So modules is actually a more reliable way of finding out what's available on a particular machine. But if you're looking for which machine to use because you need a certain software, you should go to the WestGrid web page, and you can search for the software you like, you want to use, and you get a list like this. So here I've shown a program called Abyss, and it shows you on which machine it's installed, which version is available, and how to set the module command. You should note that the name of the modules are different on each machine. So as I said, on Jasper, we've organized it according to whether it's an application or otherwise. On other places, it's not organized in the same way. Or here, for example, on Bugaboo, modules are not used so much, and so it's in the default path. So if there's software that is not on the list or is not in, you don't find it in the modules, you have some options. You can install your own. You can install any programs in your own home directory. You can request installation. If you're not comfortable with installing programs, we can do it for you, either, again, in your home directory, or if we feel that it's widely applicable, we may install it in the system library. And as I mentioned, we have some U of A only programs, and other sites as well. They have, especially for commercial programs, they have local licenses, so you may be able to find some of these installed on your local machine. So, for example, MATLAB is fairly widely available on various WestGrid machines for local use. Okay, so let's do some exercises. So hopefully you are in the workshop directory. And the first thing you have to do is load the compiler module. So I would like everybody to type module load compiler /Intel 13.0.1. That sets up the environment for the Intel compiler. The Intel compiler, the C compiler is called ICC, and the Fortran compiler is called iFort. And so you can choose whichever language you want to work with. You can compile this program this way. So ICC -O. So this is an option to tell the compiler what you want the executable to be called. So in this case, I'm calling it hello. And then hello.c is the source program. And similarly for ifort -o hello and then hello.f90. And once that's done, you can run it with by typing /hello. Now here you need the / because otherwise the system doesn't know where to find this hello program. The / indicates that it's in the current directory where you are. So can everybody do that, please? Julieta, you have to type ICC space -o space hello space hello.c. Which directory are you in? You have to be in the workshop directory. Can you? Yeah. By the way, you should avoid copying and pasting from the presentation slides because that often copies invisible characters, which make it fail. So you have to type everything in by hand. Anybody else not being able to do this? Okay. Since we're going to be using a cluster, I show you how to compile a parallel program. One of the common common way to make parallel program is using something called MPI. It stands for Message Passing Interface. And to do that, this time you need to load a different module. So this is the OpenMPI module. So you do module load library /OpenMPI/1.6.5-Intel. And now the compiler is called either MPI-CC or MPI-F90 for Fortran. Otherwise, the command looks more or less the same, except now the source code is called hello-mpi.c or .f90, and the output will call hello-mpi. And the way you run MPI programs is a little bit more complicated as well. There's a program called MPI exec. Sometimes it's called MPI run. And then you give a flag for the number of cores you want to run the program on, or processes. So minus NP gives you the number of processes you want to run, and here I've specified 2. Again, you need to specify / for the local current directory, hello-mpi. So can everybody try that? Okay, so we're going to go on. And I'll talk a little bit about man pages. The man pages are sort of the default documentation in Unix systems. So we've been using the command ICC, which is the Intel C compiler. If you type man ICC, you should get a page of documentation for this program. To get another page, you can press the space bar. You may notice that this one is a fairly large document, and often you want to search for a particular item in the man pages, and you can type / and whatever the search term, and that will go to the next occurrence of that term. And then when you're done looking at the page, you can type Q for quit. The problem with man pages in Unix is that if you don't know what the command is called, you can't use it. So there's another way to use the man command, which is with the -k option, and then you can do man -k and whatever topic you're interested in, and that will give you a list of man pages that are related to whatever the topic that you're interested in. It doesn't always give you the man page you want, but it's a way to start. Now, if you're going to be using any of the WestGrid machines, you will have to learn to use some editors. There are some graphical editors that are available on WestGrid machines. 2 of them are called NEdit or gedit. You should be able to find one or the other on any of the WestGrid machines. And for people that aren't used to using Unix, these are the editors that I would recommend people use. There are non-graphical editors as well. VI is a very fast editor that I use, but I wouldn't recommend it for beginners because the commands are rather awkward to remember. Emacs is also another popular one, and it has a friendlier interface. One that I didn't mention here is called Nano, which is fairly easy to use, and that may be preferable to VI or Emacs. Now, it is possible to edit through WinSCP, so you would be doing editing on your Windows machine, and the WinSCP would automatically transfer the file for you. This is not recommended because of the differences in the way the files are between Windows and Unix machines. So I would encourage you to learn to use one of the Unix graphical editors and do the editing directly on Jasper, for example. So with that in mind, I would like everybody to open up an editor. I think for this workshop, just start up NEdit or gedit. I'm not sure which one works. I think NEdit certainly works on Jasper. And type in these lines. You can call this file anything you want, but you can use job.pbs, for example. So for now, just type in this, create a file, type the lines in, and don't do a copy and paste. Just type all these lines in, and I'll go through what this means in a little while. Yeah, you should put in your real email address. If you have trouble seeing the slides for whatever reason, you can download the slides from what I just pasted in. If you can't see the chat window, it's also in the WestGrid website. I guess I can find that, I suppose. Well, I still can't paste that in. So if you go to the page announcing this workshop, there is a link, I think near the bottom, to the slides. So if you have, for whatever reason, trouble seeing the slides.
Masao, it sounds like just asking, they were able to see them originally, but then they lost your feed. So I'm wondering if you might need to reshare your screen if it dropped for some people.
Okay, I will try that. That worked, I guess.
What's up?
Hi, to the person who just joined, if you could please mute your microphone? Thank you.
Anybody having trouble creating this file? Okay, so I'll just go through a little bit. So all the batch jobs are written as a script. In Unix, there are something called shells, which define basically your environment, your basic environment, and it's also a scripting language. The one we're using here is called a bash script or shell. And the first line, the hash exclamation bin bash, just tells the system that this is a bash script. All the lines, in general, for a bash script, the hash character says that it's a comment, except, of course, in this case, the first line, and in this case, also the ones that have PBS. Now, the hash PBS lines is it tells the batch system that these are commands for the batch system. So these are special characters, and these lines must come before any command you give to the system. So these are especially for the batch system. And the first line, the -S/bin bash, just tells the batch system that we're working with the bash shell. The next line, all the ones starting with -L, these are L's, lowercase L's, is telling the batch system what resources you need to run your batch job. So in this case, prox equals 1 says I want 1 core or 1 processor. PMEM equals 2,000 megabytes is saying that I want a per core memory of 2,000 megabytes. So in this case, they only have 1 core anyway, so that's the total. There's another parameter called mem, which refers to the total, but I find it more useful to use PMEM all the time. Wall time is the actual time that your job is going to take. If your job runs beyond that time, the job will get killed. The PBS-M is saying that I want email sent by the batch system. And the BEA is saying that I want email to be sent when the job begins, when the job ends, or if the job aborts. And the capital M is saying where to send that email. So these are all commands to the batch system. Now, after all that is done, you can start typing in your actual job. And the first one that I have here is using an environmental variable defined by the batch system. So all the environmental variables defined by the system start with PBS. In Unix, you refer to environmental variables by putting a $ in front. So the variable itself is called PBS_O_workdir. And by putting a $ in front, you will get the value of that variable. So what I do here for this variable is the directory where you submitted the job from. So by doing CD and $PBS_O_workdir, you will change directory to the place where you submitted the job from. If you don't put that in, normally when your job starts, you start in your home directory. And for most people, you would put different kinds of work in different directories, and you would put your batch script in that directory as well. So you would change directory the first thing that you do. And by using this variable, you don't have to worry about where that directory is. And then it will, here I have the example of running the hello program. So now to actually submit the job, you use the qsub command. So in my case, I put that my job script in a file called job-jasper.pbs. In Unix, the extensions are arbitrary. I just use .pbs because then I know it's a job script. Can everybody just submit their job? So you would type qsub and then whatever you call that script name. And that should return with a job ID if it worked properly. Now you can query the state of your jobs by using the qstat command. Here I do qstat -u Fujinaga. That will tell me just my jobs. If you do just qstat, it'll do everybody's jobs. And on a busy system like Jasper, you get pages and pages. So usually you want to restrict it to just your own jobs. And well, on the test cluster, you probably won't get this line. The first thing it's going to have is, so this is your job running or queued, submitted to that system. Here in this column, under S, is the state of that job. And so initially, you would have a queue state. So it's just waiting to run. Once it starts running, it's going to change to R. And once it's done, it will change to C. And after a while, that will disappear. Your job will completely disappear. It won't show up at all. So can everybody try submitting their jobs that they've created? So you just need to type what it says on the screen, qsub space, and the file that you created. Not in gedit, in the terminal window. You should, once you've done gedit, you should save it as some file. You could call it job-jasper.pbs if you want. And then you qsub that file name. And then you can do qstat to see if your job is running or it's done. If you did qsub and you didn't get a job number back, something went wrong. It didn't. Maybe you could paste, Giovanni, exactly what you typed into the terminal. You need to be on if you're opening a new terminal, you need to first log into Jasper and then to CL2N230. You have to close gedit. Yeah, once you start gedit, you've started a program, so the terminal becomes unavailable. So you have to finish using gedit, and then you'll get your terminal back. Yes, you do need to save the script. It'll probably ask you if you haven't saved it yet. Julieta, when do you get the message no such file or directory? When you run qsub? You're not in the right directory. Did you create the file? Maybe you created in the wrong directory. It has to be in your workshop directory. Yeah, Gemma, I see jobs with a C status right now, so everybody's job have terminated. I mean, this isn't a very long job, so as soon as you run it, it probably will run and finish right away. So Giovanni, if you have a script called script-go, you just type qsub space script.-go. That should be in the workshop directory though, because that's where the hello program is. You need to have compiled the hello program as well. Giovanni, you need to type in the workshop directory. So if you do pwd, it should tell you that you're in the workshop May 2016 directory. And then you need to type qsub script-go. Email notifications. I'm afraid that it won't work on the test cluster, I think. Yes, yes. No, it will work. Okay, I'm told it should work. So maybe you have to check your what you put in the email lines. Well, I suppose I can try as well. Okay, I hope everybody succeeded in running a job. Still not sure about the email, but you may have seen, you can type ls to see what files are in your directory. And if you do that, if your job ran at all, you will see two new files. Now, these are the so-called standard output from the job, which is basically what you would see on a terminal if you were just typing commands. So these are the outputs that you want to see, and these are the files have the form, the job name, which would be a script name, .o, and then the job number. You'll get another file which looks similar, except there's an E, and these are the standard error files. So if your job had any errors at all, you would have something in this file. So you always want that file to be empty. Otherwise, you may have had errors. Now, some of the common errors that you can have. First, you're out of wall time, so you didn't give enough time in your resource request, or out of memory, and similarly for not enough resource request. The next common ones are because you've been editing your file in your Windows machine, and your batch script is in a DOS format, and so it has strange characters as far as Unix is concerned. And one of the other things that happens when you edit files in Windows is that it's missing an end-of-line character at the end. So these are reasons that you should learn to use an editor on the Unix system. Another common error is that you put in a Unix command before all the PBS lines. So after the first Unix command, the subsequent PBS commands are ignored. So you may have given it resource requests, but they are not counted. So for example, the default memory, if you don't give the memory, is I think 256 megabytes. And so a lot of programs won't run with such a small memory. Okay. I want you to compile another program. This is for demonstrating more how you would input things into a program. So there's another program called pi. Just calculates pi. So you can compile it with ICC space -o space pi space pi.c.
Joy, before we go on, can I ask you a quick question?
Okay, sure.
Do you have advice in terms of how to know what to put for the resource request in terms of memory and wall time if you haven't run the program before?
Well, if you've never run the program before, I would put in, well, basically as I had, let me just go back. PMIM of 2,000 megabytes is good because it's the amount of memory that's sort of associated with each core that we have. You can't, the machines that we have, they share memory, so you can use more than that. But that's sort of the per core memory that the machines have, so it's a good starting point.
Mm-hmm.
Well, procs, you need to know whether your program is serial or parallel.
Yeah, that.
Yeah. Yeah. I'll get into more about running parallel programs a little bit later. Wall time, you can, well, you should have some idea, but you can, for testing, you can certainly put in 5 minutes, right? Then you'll see whether there are any problems with your script, whether the program starts up. Once you know that the script itself is fine, you can try 24 hours. The maximum wall time on Jasper is 3 days, 72 hours. If you need longer, if your job takes a longer time, you will need to use other machines. Other machines on WestGrid have longer wall times. It can be as long as, I think, 3 months on Bugaboo.
Okay.
But it's not recommended to run such long jobs because the chance of failure becomes large for long-running jobs. It is better to have jobs that are shorter for turnaround anyways.
Right.
So if you can make up your job to run within 3 days, for example, it's better in general.
Right. Okay. And sorry, one follow-up question. After you've run your program, do you get a report on the actual memory used? And
yes, in your email, if you put in the email lines, you will get how much resources that you've actually used, so that subsequent runs you can reduce the amount that you ask for.
Okay, great.
And that will help run the program more quickly.
In the queue.
Yeah. The smaller your, well, because the smaller your request is, the more likely to run sooner. The other important thing about having email is that you also get error messages that you wouldn't get otherwise, like running out of memory. So it's always good to have the email notification.
Okay, thank you.
Any other questions? Okay. So we were doing the Pi program, so can everybody compile this and try running it? This is like sort of like, well, you would run it the same way as you ran the hello program, but now it will ask you for input from the terminal. So this is the standard, so-called the standard input. If you're not getting an error, ICC not found, you didn't do the previous one, or you've logged out in between, you need to load the Intel compiler module again. So if you do module avail, you will see under compilers what the Intel compiler is called. The Intel compiler module is called, so you need to load that module again. So I put this example in because it may be that the program that you're interested in running works in a similar way that it expects input from the terminal. So it looks like an interactive program that you can only do if you're at the terminal typing it in. And I'll show you how you can turn that into a batch job. Yeah, so you do have to load the module every time. You can, if you find that it's a pain in the butt to do that, there is a startups file that will automatically do it for you. If you're in Bash, there's a file called .bash_profile that you can put the module load command in, and then that way you can have this module loaded all the time when you log in. But you also need to load the module in when you create a batch job as well. There are different kinds of startup scripts. In Bash, they could be called .bashrc or .profile or .bash_profile, and it depends on the way you connect. So it's tricky to remember which one goes where. So I find it just easier, at least in a batch script, to put it into the script itself. Giovanni, which commands do you want to see the list of? What kind of commands? You mean the bash, the startup script? If you mean the startup script, then if you do man bash, it's rather a long list. Let me just see. So if you type man bash and then let me just do it again. And then you can search for invocation in capital letters that describes the various startups files. And by the way, if you create, so in Unix there are certain files that start with a dot, and these are normally invisible files, and if you want to see them, you need to do ls-a to see them. Okay, I hope everybody's had a chance to play around with the Pi program. So the way to do it in a batch script, there's a couple of ways. One is to create a file. So you can create, for example, a file called pi.n and put the values that you want in it. So the program wants a 0 to finish the input, so you would always finish the contents of that file with a 0. The example I show here, so you run the Pi program as before with a /, and then you use a left angle bracket to indicate this is a standard input. So whatever you used to type into the program, you will you would take from this file pi.n. Now, similarly, with a right angle bracket, you can specify the standard output. So what used to come out on the terminal, you can put it to a file. In this case, I called it pi.out. Now, the alternative way to put in input uses no input file. So this can actually go directly into your batch script. And here you use a double left angle bracket and some arbitrary set of characters. In this case, I've just chosen EOF-pi, but it could be any set of characters you choose. And what you need to do is that the lines that follow correspond to the standard input. So in this case, I have 100, 1000, and 0, and then the characters that I specified here, the EOF minus pi. And so that tells the system that the standard input of this pi program should come from what follows subsequently until you find the EOF pi characters. And here I also had the standard output going to the file pi.out. So this is the way you would put into your batch file a program that expects input from a standard input. As I mentioned, if you really need some interactive work, for example, a lot of graphical programs, they only take input from the graphical interface. And so if you need to do that, there is an option to do it in a batch environment, and that's by specifying a minus capital I to the Q sub. You would also specify resource requirements following a minus lowercase l. So here I've specified prox equals 4 and pmem 2000 megabytes. And that will submit a batch job that requests these resources. And it's going to sit there until those resources become available. So this is the problem of using this method. If you do it now, you'll get this resource right away because we have a dedicated cluster which is basically empty. But if you do this on a busy system, it can take hours or even days before you'll get a response. So this is sort of a last resort kind of way of doing things. And as I mentioned, it's often for graphical programs, and in this case, you also need to add a minus x. And so these things take no batch script. You can specify one, but it only you take the hash PBS lines. And anything else, all the Unix commands, you'll have to type in yourself. And you may have to wait a long time to get a prompt. Okay. Now, I want to talk a little bit about benchmarking. You're going to be using a cluster, and most of the time, many of the times, it will be for running a parallel program. And it's very important that you optimize your programs and to use the right number of processors for your parallel program. And so it's important to time your program, and the timing has to be reproducible, which means usually that you have no other users on the compute nodes that you're using, and you want to use the time command to give you the timing. So there is a command called time, which allows you to time various programs. And what you're interested in is the wall time or the actual time, physical time that it takes, not the time that it's in the CPU or whatever. So, and so for parallel benchmark, you don't necessarily want the sum of the time it takes on all the processors that you're using, but it's the actual time in the physical world. and to know how efficiently your parallel program is running. So as you add, for parallel program, as you add more and more processors, hopefully it runs faster and faster, but at some point this will level off and even start to become worse again. So you need to find that optimal point. So to do that, I have a benchmark exercise. There's a program called sample1.f in the workshop directory, and I want you to compile it with an MPI Fortran compiler. So you need make sure that you load the OpenMPI module in order to use that, and type MPI F90 space minus little o space sample1 space sample1.f90 space minus fixed space minus capital O0. So the capital O0 sets the optimization level for the compiler, and I've set it to 0 because just for demonstration purposes. Normally that would be either minus O2 or 3, and there are other flags that we'll talk about a little later. And the minus fixed is just the way that I've written this Fortran program, so it refers to the format of the Fortran program. So once you've compiled it, you can submit script1.pbs. If you look in the script, you'll see that it actually runs the program 5 times. I didn't fix this one. 5 times, changing the number of processors from 1 to 12. Now, I've used the time command, so it will tell you what the time it's spent for each of these runs. And the number that we're interested in is the real time. So you can use the command grep, which will grab those lines that contain the characters real. And so if you do grep real out.time, which is the output file that I'm using, you will get the timings for those corresponding to those processors. And once you get that, I want you to plot these using Wolfram Alpha. So you connect to the website, www.wolframalpha.com, and you can paste in, or well, type in, it's always safer to type it in, this plot command, replacing the values for T1, T2, T4, T8, T12 with the values that you got. And that shows you the time as a function of the number of processors that you have. And you can also plot the speed up using this formula, and that will show you the speed up. Okay, so I'll let you work on that. Giovanni, did you type in exactly what I typed in? I guess you do get that warning. Oh, no, I don't. Yes, by submit, I mean QSub. Giovanni, you should be in the workshop May 2016 directory. Yeah, if you were somehow not there, you would have to make sure that you're logged into Jasper, you're logged into CL2 and 230, that you have the OpenMPI module loaded. You can check if you have which modules you have loaded by typing module list. Giovanni, you seem to have started a interactive batch job, so you need to log out from that window. Yeah, so you need to connect to www.wolframalpha.com in your web browser, and then you should get a little place where you can type in the plot command. So I hope everybody was able to run that and plot it. You should have gotten plots that look somewhat like this. So this is the plot of the time versus the processor number. And so, oops. You should start somewhere high and it should decrease like so. And if you plot the speed up, you should get a line like this. So ideally, you want the line to be a straight line. So if you use 2 processors, it should go twice as fast. If you use 4, it should go 4 times as fast, and so forth. But it doesn't do that because of overheads involved in running in parallel. And so you get the leveling off effect. And so if you keep going, it'll eventually flatten out, and it'll probably start going down at some point as the overhead of running in parallel becomes more than the actual work that each of the processors is doing. So for this reason, you want to understand the parallel efficiency of your program. So you want to be running closer to you want to be running somewhere where the speed up is sort of linear. There's another factor that comes into effect because you're running on a shared cluster, and that is that the more resources that you ask for, the longer you can expect to wait before your program starts running. So, you know, your program may scale very well, and you can run 1,000 times as fast with 1,000 processors. But if you ask for 1,000 processors, it may take days or months before your program will actually start to run. So there's a trade-off between the amount of processors you want to ask for to get the best speed up, but also so that your job runs quickly. Now, there are other ways of optimizing your program. The simplest way is playing with the optimization flags of your compiler. For our exercise, we used O0, but the default optimization level is O2. You can use O3, which will give you a slightly higher optimization. You can add, for the Intel compiler, you can add other flags such as this one, which will optimize for vector processing. And you can try running for an exercise. There's a sample 2 program, I think. Yes. So this one you can compile with, this is a serial program. And you can try running, compiling, sorry, with different optimization flags. So before you did ICC minus, well, for example, pi, and then we just gave it the source code name. You can try it with the sample 2 program. And so you can compile ICC minus O sample 2, sample2.c, and then you give different optimization flags going from O0 to O3. And you can use the time command. So you would run it with the time command. You will need to make so you will have to adjust the batch script that you made initially for the hello program to run the compiled version of the sample 2 with different optimization levels. You can put these runs in the same, no you can't. You'll have to compile it each time. So you would compile it interactively, then make your batch job, run the sample 2 program, and you can see what the timing is. Now, this program prints out a number, and you can compare the numbers, because what happens with different optimization levels is that there are different ways of treating the rounding errors. So, in fact, Intel in the default O3 level not the default, just the O3 level, does some approximations about rounding. And so at this level, you will get much faster run times, but the numbers aren't quite the same as you would have gotten with O0 or O1. And to get those numbers back, you need to add the flag minus FP model precise, and then you will get the same numbers, but then the run will be not as fast as it used to be. So try compiling the sample2 program, just as you did for the hello or pi program, using ICC. Make a batch job and try running it. So you would compile it with O0, run your batch job, compile it with O1, run the batch job, and see what numbers you get. So I'll let you do that for about 5 minutes. Yeah, Giovanni, the plot was you had to go to the Wolfram Alpha site to do the plot. Actually, you probably don't need to bother with a batch script, even though I said that you should be working on a empty system. It's probably not, so you can't try running it interactive. Well, you can try both. You can try running it in batch. You can try running it in interactive and then see what the differences are. Okay, so this exercise, you need to compile sample2. So there's a file called sample2.c. So you would use the same command as you did before. So ICC to compile this program. So you would call it, you would put the output to -O. So ICC space sample -O sample2 space sample2.c. And then you can start with -O0. Try running that program with a time command. So you would type time space /sample2. And that will give you the time for running that program. Type on the screen. Okay. Going to run out of screen space here, I'm afraid. Try to make a small. That's too small. That may be too small too. So, for example, that's how you would, well, and then so that's how you would compile with -O1 and then running the program. Yeah, the checksum value that you want to get is the same one as you would get with -0, but you can see that with -03, for example, you'll get a different value, but it's different by a very small amount. So if your calculations are not so dependent on such precision, then you can, you gain a lot by going faster optimization. So it depends on the nature of the calculations that you're doing. If you need that precision, then you do need to run slower. And so I'll just let you play around with that on your own time after the workshop. The cluster will actually be available for another week or so, because Camille is doing another one next week. So I'll just go on. Another easy way of speeding up your code is to let somebody else do the optimization, and that's been done in various libraries that you can have. The Intel compiler comes with a library called the math kernel library, which contains a lot of the linear algebra routines like BLAS or LAPACK. And you can just use those routines by adding -nkl equals sequential. The sequential part is needed because otherwise the MKL library actually has been parallelized, and it will try to use all the cores on a particular node. So if you're running your job on Jasper, it'll try to use 12 cores, or maybe even 24 because we have hyperthreading turned on. And you don't really want to do that. You only want to use the cores that's been assigned to you. So it is always safer to use just sequential. So you don't, on our machines, you may not get the most speed up you can possibly get, but it prevents interference with other people or even yourself. Just a few words about file systems. So the directory that you log into is called the home directory. On most WestGrid system, there is also a Scratch directory called /global/scratch/ your user ID, where you're expected actually to do all your work, because this is the place where you have the most space available to you. A lot of them have a quota of 1 terabyte on that file system. Not all of them, but it would have, in general, a lot more quota there than on your home directory. On Jasper and on Hungaby, this is not the case. We only have the home directory, and that's where you have 1 terabyte quota. And you can find out the quota by typing LFS quota -u, your WestGrid ID, space, and then luster. So that you can try typing that to get the quota. Please note that not only you have a limit of 1 terabyte, but there's a limit of 500,000 files you can have, basically. Actually, the number is files and directories, but more or less the same thing in most cases. And for moving data, so you do have quota on all the systems, so you may start to run out of space, or you may want to have another copy of some important data elsewhere. And so Silo is the main storage site, and you can get information about Silo on our website. And the easiest way of transferring large amounts of data between WestGrid sites is using Globus. And I put the link there. The advantage of Globus is that it's a fault-tolerant system. So you can start a transfer, and then if something goes wrong, it'll restart again. And so you can basically, as they say, fire and forget. So you can start it up and go away. It can also transfer files efficiently to your desktop as well. You can install a Globus application on your desktop, and so you can transfer these data to your desktop as well. And that's basically all I have for today. So for getting help with any of this stuff or anything else to do with using WestGrid, you can use the WestGrid webpage. I find the search facility in that webpage to be most useful. If I'm looking at for a particular topic or particular software, I just type it in the search, and I find that easy to find. And the main place to get support is through the email through support@westgrid.ca. And please remember, when you ask for help, that you should specify your user ID, and most important, which WestGrid system you're having trouble with, because there are many WestGrid sites, and we can't tell which one you're working on. Job ID, if you're having trouble with a batch job, it's useful to give us the job ID. Then we can track down what happened to that job. Error messages that you got, and don't forget to look in the error output file. You may be able to diagnose your problems just by looking at your error output file or the email message that you got. And if you're having trouble running a script, please tell us your script location so that we can have a look. Are there any questions? Okay, so no, if there are no questions, thank you very much for coming, and I hope you got something out of this talk. And again, if you have any further questions later on, just send them to support@westgrid. Okay, thanks.